Alright, so what we're going to be doing in this video is we're going to be working on a few integration by parts problems. So we're going to be doing these problems using the integration by parts formula, and that's the integral of u dv is equal to uv minus the integral of v du. Now sometimes you could see this formula written as the integral of f of x g prime of x dx is equal to f of x g of x minus the integral of g of x f prime of x dx. Alright, so let's go right ahead and get into the problem here. The first problem is the integral of x squared ln of x dx. So we're going to be using the first form of the formula, the integral of u dv equals uv minus integral of v du. So what we want to do is we want to choose our u and our v first. So we can choose our u to be equal to ln of x, and we can choose our dv to be equal to x squared dx. So if we choose this to be our dv, then that means our v is equal to the integral of x squared dx, which is just x cubed over 3. Okay, so here we have our u and we have our v. So we can go ahead and just plug this right into the formula here, and if we do that, we're going to get the integral of x squared times ln of x dx is equal to u times v, right? Our u is ln of x, our v is x cubed over 3. So we're going to have x cubed over 3 times ln of x, and then minus the integral of v du. So minus the integral of v, which is x cubed over 3, x cubed over 3, and then du. Du is the derivative of u, right? Let me actually fix this. This looks like a u. We can write this is dv, but we're talking about du. So the derivative of u is the derivative of ln of x, and the derivative of ln of x is 1 over x. So let's go ahead and write that as 1 over x dx. Okay, so the x cubed cancels out with one of the x, with the x on the denominator, and this gives us x cubed over 3 times ln of x minus, and I can bring out the 1/3 here since it's a constant. I can place it outside the integral, and then x cubed over x is just x squared. So minus 1/3 the integral of x squared dx. So if I integrate x squared, I'm going to have x cubed over 3, just like before. So now I'm going to have x cubed over 3 times ln of x minus x cubed over 3, and then times the extra 1/3 on the outside, right? So this is going to give me x cubed over 9. So let me just go ahead and write that. So this is going to be x cubed over 9. And this is our answer for the first problem. Of course, let's not forget the plus c. So plus c plus a constant. So this is our answer. Alright, let's move along to our second problem. Here we have the integral of theta cosine of theta d theta, and we're still applying the same form of the formula. And in this case, our u is going to be, let's see, we can choose u to be theta, and we can choose our dv to be cosine of theta d theta. Okay, so sometimes the problem that a lot of students have is knowing how to choose the u and the dv, right? So it's not like you don't know how to apply the formula. It's just how do you choose your u and your dv? And what usually works for me is taking a look at the formula and seeing which u and v I can choose so that the outcome becomes a lot simpler than the way the integral was before, right? So if I take a look at this first part of the formula, right, I try to choose my u and dv such that this integral becomes very simple, right? And what makes this integral simple? Usually it's the du. So I try to pick my u to be a function so that when I take its derivative at the last part of the integral, the derivative is something very simple so that when I integrate v du, I can actually get an answer, right? Sometimes you can choose the wrong function, and when you end up integrating v du, your result becomes even more complicated than it was before. So be very careful with that. So here I chose my u to be theta, my dv is cosine of theta, d theta, and which means my v is going to be the integral of cosine of theta d theta. And the integral of cosine of theta d theta is simply sine of theta. Okay, so let's go ahead and apply the formula. We have the integral of theta cosine of theta d theta is going to be u times v. So that's going to be theta times sine of theta. So theta times sine of theta. And then minus the integral of v times du. So my v is sine theta. My du is the derivative of theta with respect to theta. Okay? So the derivative of theta with respect to theta is just 1. Right? So this is going to be sine of theta multiplied by 1 times d theta. Okay? So my integral is theta sine theta minus the integral of sine of theta d theta. Okay, so let me go ahead and write that a little bit simpler. I can get rid of the one that's being multiplied here, and I can just write this as sine theta d theta. Okay, so this is going to turn out to be theta times sine of theta minus the integral of sine of theta. And the integral of sine of theta is just negative cosine of theta. So this is going to be negative cosine of theta and then plus c, which is just, of course, after the negatives cancel out, you have theta sine theta plus cosine of theta plus c. Alright, so let's keep working here. Our third problem is the integral of x cosine of 5x dx. So we're going to go ahead and choose our u. So remember what we talked about? We want to choose a u and a v such that this integral turns out to be very simple to integrate. So what I can do is choose my u to be x, because then when I take its derivative, I'm just going to have 1. Alright? So I can choose my u to be x, and my dv is going to be cosine of 5x dx. So cosine of 5x dx, which means my v is going to be the integral of this, which is just 1 over 5 sine of 5x. Okay, so if we plug this into the formula, we have our u times dv, so that's going to be our x cosine of 5x dx is equal to uv, so that's going to be x over 5 sine of 5x minus the integral of v du. So this is going to be minus the integral of v, which is 1 over 5 sine of 5x. So 1 over 5 sine of 5x, and then du, the derivative of x, so it's just 1 times dx. So we can write this as x over 5 sine of 5x, and then I'll bring out my 1 over 5, and I'm going to integrate sine of 5x dx. So the integral of sine of 5x dx is just going to be negative 1 over 5 cosine of 5x. So let's go ahead and write this as this is equal to x over 5 sine of 5x minus 1 over 5, and then times the integral of this, which is just going to be minus 1 over 5 cosine of 5x, and then plus c. So that means that our answer is going to be 1/5 of x times sine of 5x, and then the negatives cancel out to make a positive, so we have plus 1 over 25 cosine of 5x plus c. Alright, so our last problem for this video is going to be the integral of y times e to the 0.2y dy. So let's go ahead and choose our u. Our u is going to be y, which means our du is going to be dy. And our dv, we're going to choose to be e to the 0.2y times dy. And so our v is going to be the integral of this function. That's going to be 1 over 0.2 e to the 0.2y. And we can write the 1 over 0.2 as simply 5. So this is going to be v equals 5 times e to the 0.2y. So if we plug these values into our formula, we're going to find that the integral of y times e to the 0.2y dy is equal to u times v. U is just y. V is 5 e to the 0.2y. So u times v is 5y e to the 0.2y, and minus the integral of v du. So that's going to be 5 times, let's see, v is 5e to the 0.2y, and du is just dy, so times dy. And we can write that here as 5y e to the 0.2y minus 5 times the integral of e to the 0.2y dy. So if we integrate this over here, we just get a 1 over 0.2 times the original function, right? When you integrate e functions, you usually get the original function back. So this is going to be 5 times y times e to the 0.2y, and then minus 5 times this integral here evaluated, which is going to be 1 over 0.2 times e to the 0.2y, and plus c. And again, we can take out the fraction here, the 1 over 0.2, and we can write that as simply 5. So we can have this, the integral, the solution to the problem, is going to be 5y e to the 0.2y minus 25 e to the 0.2y plus c. So thanks for watching, guys, and I'll see you again next time.